Hello, and welcome to SYSVIEW, a 360-degree tour for beginners. My name is Sean McShane, and today I'll be taking you through the basics of what SYSVIEW is, how SYSVIEW works, and how exactly to use the product. Now, before we can begin to talk about how SYSVIEW works exactly, we need to first define what SYSVIEW is. SYSVIEW is a mainframe performance monitoring and management tool. What this means is that SYSVIEW is a piece of software that runs on your mainframe and allows you to get a deep dive look into your mainframe internals. This allows you to effectively monitor the status of your machine. It is important to have software like SYSVIEW, as running a mainframe can be quite costly and you want to make sure you're getting the most bang for your buck, and that's exactly what SYSVIEW allows you to do. SYSVIEW supports both the z/OS operating system and several other common subsystems, like CIX, IMS, MQ, and several others. This makes SYSVIEW quite convenient, as it can be used as a one-stop shop for monitoring your mainframe. By using SYSVIEW, you have access to both real-time and historical data. The real-time data allows you to know how your system is performing at that point in time and can be important when identifying and resolving any problems. The historical data allows you to have a sense of how your system is performing over time, for example, seeing how the system performs during peak hours. This allows you to identify any trends that might need attention. SYSVIEW allows users to define their own thresholds which match against the data that SYSVIEW is collecting. If any of these thresholds determine there is a problem, you can be alerted so that you can take quick action and resolve any issues. SYSVIEW allows you to monitor your entire Sysplex through cross-system communication. This allows SYSVIEW to talk to other instances of SYSVIEW within the Sysplex so that you can monitor and manage multiple LPARs from one SYSVIEW instance. Finally, SYSVIEW is useful for almost anyone interacting with the mainframe. One does not have to be technical to navigate and understand the product. However, SYSVIEW contains quite a lot of functionality, so being more technical might allow for quicker adoption and understanding of some of the features. Now that we know what SYSVIEW is, we can begin to describe and take a look at how SYSVIEW works. So, to begin with, I will explain the SYSVIEW address spaces. SYSVIEW is composed of at least two address spaces. As we will see, these two address spaces provide a separation of the front and the back end. The first of the two required address spaces is the main services address space. This address space is responsible for running any authorized functions and makes up the back-end functionality. Data collectors, loggers, and SYSVIEW scheduler run under this address space. The second required address space is the user interface address space, which, as the name suggests, is responsible for handling user sessions and makes up the front end. This address space also handles cross-system communication, which allows SYSVIEW to communicate with instances on other LPARs. It is important to note that for a given instance of SYSVIEW, there can be only one main and one user address space running at any time. The third and final type of address space that SYSVIEW provides is the auxiliary services address space. There can be multiple instances of this address space at any given time. The main purpose of this address space is to run CIX logger tasks, as CIX logger tasks can potentially be quite resource intensive, so partitioning these out to other address spaces can be a good idea in some cases. We will now dive a little bit deeper into some of the back-end functionality. The main concept behind SYSVIEW is that of data collection. At a high level, data collection can be defined as identifying, collecting, and storing data. In order to present data to the user, SYSVIEW must first collect it from the operating system and various subsystems. To do this, SYSVIEW has several data collector subtasks specific to the areas where we are collecting data. These subtasks run under the main address space, but parts of CIX and JVM data collection run in other address spaces. For example, the CIX data collector runs in the specific CIX region address space. While these data collector subtasks differ in the data that they collect, they all follow a similar process, which can be seen in the graphic on the right side of the slide. When the data collector first starts, it will read in configuration options from various parmlib members. The parmlib is just one of the many libraries that SYSVIEW manages, as we will see shortly. Once the data collector has its configuration, it must discover where the resources it is interested in are living at, as data can move around. Once this location is discovered, the subtask can begin to collect the data. The process of collecting data can be driven in two different ways. The first is that of an interval driving data collection. As mentioned previously, SYSVIEW scheduler runs under the main address space. The scheduler defines the intervals on which the subtask will collect data. So, for example, if the MVS data collector is set to run every 5 minutes, then the subtask specific to MVS data collection will collect data at every 5-minute interval. The second way that the data collection is driven is through events. An event, for example, can be a CICS region becoming active. This event will be detected by SYSVIEW and data can begin to be collected. Once the data is collected and stored in memory, SYSVIEW can begin to analyze the data. As mentioned before, SYSVIEW allows users to define their own thresholds to be used to classify problematic situations. When the data has been collected, the next step is exception processing, which will check the collected data against the user-defined thresholds, which may result in alerts if any of the data is considered problematic. Some of the data collected is eligible to be written to SYSVIEW log streams, which is the next part of the data collection process. By logging data, one can have a record of how their system has been performing over time. The final step in data collection is the external data interface. This external data interface is responsible for responding to commands coming from SYSVIEW user sessions. Now that we have mentioned log streams, it is important to talk more about them as SYSVIEW manages several types of log streams. The different types can be seen in the table to the right of the slide. Some of these log streams are specific to SYSVIEW, like the audit log stream, which will log any defined audit events, like users signing on and off. Other log streams are specific to subsystems. For example, there are several CICS log streams. While they may hold different data, all of these log streams are written to in an SMF record format. However, since the log streams hold different data, it's possible that the rate that the log streams are being written to may differ. Because of this, it is important to take time when sizing the log streams at definition time. For example, the CICS detailed transaction record log stream writes a record for every transaction that executes in the region. There can possibly be a large number of transactions running in the region, which would cause the rate of writing to this log stream to be quite high, and in order to stop the log stream from constantly filling up and having to be offloaded, the log stream must be sized appropriately. Help for sizing these log streams can be found within SYSVIEW and also on our DocOps site. As a final note on log streams, these log streams can be viewed online from within SYSVIEW in order to see their contents. The log streams can also be used as input to batch jobs in order to report on or do various other things with historical data. As we mentioned previously when talking about the data collection process, SYSVIEW owns and manages several different libraries, one of these being ParmLib. The other libraries contain sample JCL members, help members, and various other members responsible for making up SYSVIEW. SYSVIEW introduces 3 different library types that these different libraries may be eligible for. These 3 types include system, site, and user. Not all of the SYSVIEW libraries are eligible for all the different types, which can be seen in the graphic to the right of the slide. The system type is a required type for all libraries and contains definitions shipped with the product and is usually not modified. The site type contains definitions that are specific to a given environment. Finally, the user type contains definitions specific to a given user. These 3 types are concatenated with user being on top, followed by site, and then system. When SYSVIEW goes to read a library member, it will check this concatenation, and whichever type of the member it finds first, it will be used. You can use the libs command from within SYSVIEW to view the contents of these libraries. Now, when discussing SYSVIEW's library structure, it is also important to discuss SYSVIEW's library cache. This cache is the same as other caches you may be familiar with, as the point is to reduce I/O usage when reading in certain members. This can allow SYSVIEW to start up quicker. The library cache mechanism is not required and can be toggled on and off. Not every library is eligible to be cached, and in the Options ParmLib member, you can specify which of the eligible libraries are to be cached. From the lib cache command within SYSVIEW, one can view and interact with the contents of the library cache. By using line commands, a user can delete or reload members of the cache. This cache is emptied after every restart of the main address space. This concept of a library cache can potentially introduce some confusion when using SYSVIEW. For example, say you make a change to a Parmline member and then go into SYSVIEW, but you do not see the expected updated behavior. It's possible that the member was cached previous to your change, which would result in the older member being read in. To circumvent this problem, you would either have to delete or reload the member out of the cache in order for the new updated Parmline member to be read in. I will now jump over to SysView and do a live demonstration of using the libs and the libcache commands. Okay, so now that I'm in SysView, I will now demonstrate the libs and the libcache commands. I can enter these commands from within SysView on any display using the top command line. I'm currently sitting on the primary option menu, which is the default display for whenever you enter SysView. So I will now enter the libs command using the top command line. Now that we're on the libs command display, we can see different information regarding the SysView libraries. You can see the name of the library, the different types of the libraries that we discussed earlier, and also the dataset names that the libraries are defined to. Now, if you recall, not every library is eligible for the 3 different types, and if you were to have a library that was not eligible for a certain type, you would see unsupported under the dataset name. And if you have a library that is eligible for a certain type, however, if you have not defined a dataset name for that type yet, you will see undefined. Off of this display, you can actually view the contents of the different libraries. So if I were to go down to the site parm lib here, using different line commands, I can enter LD here for list directory, and this will actually show me the contents of that library. And if I scroll down here, I can use line commands once again to actually view the contents of that member from within SysView. So if I use a B line command here and press enter, I will see the contents of that C thresh member. Okay, so I will now hop over to the libcache command. Like I said before, you can enter these commands on any display, so I can sit here on the list directory screen and actually type in libcache up at the command line and press enter. This will take me to the library cache display, and what you can see here is information regarding the library cache. Up top in the info area, you can see the different libraries that are eligible to be cached listed and indicated if they are actually being cached or not. If you recall, you can use the options parmlib member to actually exclude different libraries from the cache. So from here, you can see a bunch of different information regarding the contents of your library cache. You can see the last user to actually use the member, the last time it was actually used from the cache. If you scroll out to the right, you can actually see the last time it was put into the cache. Now this information can be very useful if you're making changes on disk and you want to see what is actually in the cache right now. So if we use line commands once again, we can actually delete and reload members from within the cache. So if I scroll down to this dashboard member, we can take a note of the time that it was put into the cache. So we can see that it was put in at 11 o'clock p.m. on 5/25. So if I were to do a reload, this should reload whatever is on disk right back into the library cache. So we should see this update here, and we do. This is the current time and date. So this shows that something new was actually just put into the library cache. As a final note before we get into discussing the startup of SysView, here is a list of the different subsystems that can be monitored by SysView. By knowing what type of system SysView can monitor, it can allow you to have a better idea of what exactly SysView can do. SysView's base component holds the ZOS, or is commonly referred to as MVS component, which allows you to see the statistics on address spaces, interact with jobs, see the status of various hardware devices, and much, much more. I will not go into detail about the other subsystems, but SysView can also monitor CICS, MQ, IMS, JVM and LE, and TCP/IP. Now before discussing using SysView, I will discuss some concepts regarding starting up SysView. When the required SysView address spaces first start, they will look for the system configuration member, which is referenced by the DD GSVX SCFG. The member name is a concatenation of GSVX and the SSID that was defined at SysView installation. This member contains various customizable options that make SysView specific to you. For example, this member holds definitions for which SysView components are active, administrator user IDs are defined here, and dataset names for the SysView libraries, and much more. This member can be shared by multiple instances of SysView, but only under certain conditions if the instances are in the same LPAR. If 2 instances are running on the same LPAR, they must be at different releases in order to use the same subsystem ID. If the instances are running at the same release, then they cannot use the same SSID, meaning they cannot share the same system config member. The SYSVIEW address spaces are run as started tasks. For the main address space and several subtasks running underneath it, SYSVIEW introduces the concept of a start type. This concept basically determines how certain library members are read in. There are two start types, cold and warm. When something is defined to run cold, all eligible library members are read directly from disk. When something is defined to run warm, which is the default, it uses a new type of technology called a persistent data store. SYSVIEW allows users to make configuration changes online. When these changes are made online, they are stored in this persistent data store. When a warm start is used, SYSVIEW will read from the persistent data store rather than reading the members directly from disk. This allows for multiple executions of SYSVIEW to operate from the same updated configuration definitions, and this persistent data store is even maintained through multiple IPLs. It is important to note that when changes are saved to the persistent data store, they are also not written out to the library members that hold those definitions. However, this can be done manually. Because the changes are not written out to members automatically, it is important to only change the start type when you know what you're doing. For example, if you were using warm starts for a while with a lot of changed definitions residing in the persistent data store and then switched over to a cold start, the persistent data store would be overridden with whatever was read in from the cold start. This would probably mean a loss of data that was being used for the warm starts. The start types can be defined in different places, which can create some confusion. For example, the start type for the main address space can either be passed as a parameter to the started task, or it can be coded in a parmlib member. Taking a look at the table on the right, we can see that the started task parameter takes precedence over what is coded in parmlib. This can be quite confusing, as if somebody were unaware of every place the start type can be coded, they can see unexpected behavior. Start types for eligible subtasks are coded in parmlib members. As mentioned earlier in the presentation, the CICS data collector runs in the CICS address space, the CICS region address space. For this data collector, a start type can be specified and used online through the CICS list command. This command provides information for every monitored CICS region, and you can stop and then cold or warm start the SYSVIEW data collectors running in the region directly from this command display. Now, since the confusion is so common regarding SYSVIEW start types, I would like to take a slight bit more time to discuss some common scenarios regarding start types. The first is that you made a change to a parmlib member and you're not seeing the expected updated behavior from within SYSVIEW. As mentioned previously, it is possible that the library member was cached, resulting in an older version being read in. However, it is possible that a warm start is being used and the member is being read from the persistent data store. This would result in this persistent data store would not contain the changes you made to the member on disk. The next two scenarios address you telling SYSVIEW to use one start type, but then seeing that another start type was actually being used at startup. This can be caused by the multiple places where the start type can be defined and the overriding precedence rules that they follow. Not mentioned previously is that if the SYSVIEW main address space starts cold, then all of the subtasks will also start cold, regardless of what their start types were defined as. When the main address space starts warm, the respective subtask start definitions are honored. So, be familiar with what definitions override others when playing with start types. Now that we have defined what SYSVIEW is and how SYSVIEW works, we can begin to look at how to exactly use SYSVIEW. The first topic we will begin with is navigating the product. SYSVIEW is a command-driven product, meaning that you enter commands in order to take action. Overall, there are over 800 primary commands, which can be a lot to keep track of. Within SYSVIEW, the commands command can be used to display a list of all commands. There are three different types of commands, with the most common being primary commands. Primary commands are used to navigate to different displays, which will display information specific to whatever function the primary command should perform. There are also subcommands, which are specific to primary commands. These subcommands allow for additional functionality on the given primary command displays. Finally, there are function commands which do not navigate to different displays and are not specific to a given primary command. Rather, these function commands perform some independent function and a message is usually output at the top of the SYSVIEW display to show the result of the command. For example, SYSVIEW provides a calc function command, which is a calculator. You pass an arithmetic expression to this command, and the result will be output near the top of whatever display you are currently on. Although there are different types of commands, all commands are issued from the main command line at the top of the SYSVIEW display. For most commands, a shortened version of the command name can be used, which can be seen on the commands display. The capitalized portion of the command name can be used rather than typing out the entire command. Some commands allow parameters to be passed. These are documented in the help for the commands, which will be discussed shortly. Finally, did you know SYSVIEW comes with a loan calculator and calendar? Another way of navigating throughout SYSVIEW is through menus. Menus are basically commands that are laid out in a hierarchy. This approach is much easier for new users and users who are more familiar with using point-and-click interfaces. The menus contain a set of related command displays. For example, there is an MVS menu that contains common MVS commands. This allows unfamiliar users to easily navigate the command displays they are interested in. To navigate through menus, one can use the menu command followed by the name of the menu. These menu commands are issued the same way as other commands. The menus can also be selected using line commands or by clicking, which allows users more familiar with point-and-click displays to be able to easily navigate the product. The following screenshot is of the SYSVIEW primary command activity. Beginning at the top left, we can see the command line input area where all the different types of commands are entered. If this area is too small for a given command string, there is a command called longcmd which allows for multi-line command input. Below the command line is the info area. Not every display has an info area, but this area usually shows a summary or high-level view of the data presented in the data area below. This info area is a great way to get a quick sense of how your overall system is performing. Underneath the info area is where formats and filters are shown. Formats define in what order columns should appear and how they should be sorted. Any display can have multiple formats displayed, and new formats can be created by users. Underneath the formats, any filters that are being used against the display are indicated. We will discuss filtering data shortly. At the top right, we can see the display and navigation area. This area shows what level you are currently at in the menu hierarchy, along with row and column information for the given display. Finally, the majority of the display is where the data fields are displayed. This area is almost always in a tabular format with field names at the top describing the columns and a row of data for each independent piece of data. For each row of data, there is usually an area to the far left of the row where line commands can be entered. Line commands allow for actions to be performed against that specific row of data. To view all of the line commands available for a row of data, you can put a question mark in the line command area and press enter. You will be presented with a list, like the screenshot presented on the slide, of all of the valid line commands for this row of data. As can be seen in the screenshot, the line commands are categorized by the type column. There are two common types of line commands. The first of these two is the type action. Line commands that are defined as an action will take some sort of action against the row of data. For example, on the activity screen, you can use an action line command to cancel an address space. The second common type of line command is the type navigate. Line commands defined as this type will navigate to a new display when used. For example, on the activity screen, you can use a navigate line command to view the output data sets of that specific address space. As has been seen previously, it's possible for some of the SYSVIEW displays to contain quite lots of data and can be overwhelming. When using certain commands, it's possible that you don't care about summaries of data and are only looking for specific pieces. To address this, SYSVIEW allows the command displays to be filtered in order to create a less cluttered view and allow you to quickly get the data that you are interested in. To filter data and only see a subset of the original data displayed, use the SYSVIEW select subcommand. When sitting on a SYSVIEW display, you can use Boolean logic along with the select command in order to create custom filters. For example, on the activity screen, you can use the command select followed by the column name you want to filter on, job name in this example, followed by a relational operator, followed finally by the value that should be used to filter. Multiple filters can be combined using AND or logic. To allow for even more customization of the command displays, SYSVIEW also provides the sort subcommand. This command allows you to view the data rows in a specific order. For example, on the activity display, if you wanted to see the address spaces sorted by CPU percentage, you could use the sort command followed by the column name CPU percentage in this example. The sort order defaults to ascending, but can be altered to descending order by appending a D at the end of the command string. You can also double-click or select the column name into order to sort by that column. We will now jump over to SYSVIEW to see the activity command display in order to demonstrate some of the concepts we have discussed thus far. The activity command shows a real-time view of all jobs currently running on the system. This command shows many metrics for each job, and an information area is also provided in order to get a quick sense of how your system is performing overall. Okay, I will now use the activity command from within SYSVIEW to demonstrate some of the concepts we've discussed thus far. Now, one way to get this command display is by typing the name of the command, activity, up at the top command line and pressing enter. This will take us to the activity command display. Now you can also get to the same exact command display by using menus. So if I PF3 back to the primary option menu, I can see different menus that I am eligible to use. Now this would be useful if you're unsure what exact commands to use to get to the information you want. So by using the different option numbers on the left side, I can type those in at the top command line. So if I choose option number 1 for the overview menu, from here I can use option number 4 for the system status menu, and then option number 2 here is actually the activity command. So this will take us to the same exact display that we saw before. Now if you recall, up at the top we have an information area which shows the summary of information provided below. Beneath that you have an indication of the formats and filters that you're currently using. In the top right you can see the time, your scroll value. The level indicator is how deep into the menu hierarchy you currently are. And to the right of that, you can see an indication of the rows and columns for the current display. Now you currently can see that we're only displaying the first 24 out of 921 rows and the first 159 out of 535 columns. So using PF keys or page up and page down, you can both scroll to the right and back to the left, or page down and go back up to see all of the information on the display. So on the left you can see the line command area, and by pressing or using a question mark here, I can see the different line commands that are eligible for this display. You can either enter the line commands back on the display using the command name, or you can select right off of here the different command that you wanted to use. So PF3 back to the activity command. I will now demonstrate using a filter. So if you recall, we can use the select subcommand, shortened to cell. We then choose a column name. I'll choose type here. And then a relational operator, I'll pick equals here, and then we'll choose started task to only see the started tasks currently running on the system. So now, by indicated by the type column on this display, we will see only jobs currently running on the systems that are started tasks. So if I were to do the select command without any parameters, that will clear our filters and go back to the default filter, which is none. Now, if I wanted to use a different filter, or a different format, I can use the formats area to actually select different formats. So if I wanted to see what is the CPU format, if I double click that, we will actually see that the display shifts a little bit. Some of the columns move around. You can see the CPU columns are kind of more towards the front now. So you can use these different formats to customize your displays. No matter the skill level, viewing help within SYSVIEW is a very common thing to do, as SYSVIEW's functionality is quite vast and it's near impossible to remember everything that SYSVIEW can do. Help is provided for every SYSVIEW command. Help for these commands describe what the command does, details any parameters that can be used, defines what the column names mean, and much more. In order to view help for a given command, you can either use the help command and pass the name of the command as a parameter, Or if you are sitting on the command display in interest, you can press the PF1 key to view help. If there is something specific you are looking for on help and don't know where to go to find this information, there is a find help command that will search all of the help members for a given string. One of the lesser known things within SYSVIEW is the topics command. This command displays a list of helpful articles based on various SYSVIEW concepts. Some of these topics include tips and best practices, which can be extremely useful to a SYSVIEW beginner. For example, included in these topics are sizing your log streams and discussion of star types. SYSVIEW can also integrate with quick reference, which allows for easy queries on various system topics. You can use the QW command to search quick reference for a given string. For example, you can search QW for system ABN codes if you are unfamiliar or just need a reminder on what the ABN means. Finally, our online documentation for SYSVIEW is hosted by DocOps. This is a great underutilized resource that holds documentation on everything SYSVIEW, including installation, helpful tutorial videos, message help, and much, much more. Every user in SYSVIEW has their own user profile. This profile contains various personalized settings specific to the user, like setting up custom PF keys, changing default formats on command displays, customizing your display, and much more. A profile with default settings is created for a user the first time they log in, so there is no action to be taken in order to create a user profile. In order to modify the profile settings, you can use the profile command. This command allows you to change the profile settings with a menu-driven experience. Once you choose a specific category within your profile to change, you will be presented with a list of all available profile settings for that category. If you know which specific profile setting you want to change, you can use the set subcommand. To use the set subcommand, you pass the keyword of the profile setting to the set command, followed by what value you want that setting to have. This way is much quicker than going through the profile command and can be a quick way to test different values for settings. By default, profiles changes are saved when the user logs out. You can also pass the keyword save to the profile command in order to immediately save any modified profile settings. In between certain SYSVIEW releases, a profile conversion job would need to be run in order to accommodate for any profile changes made in the new release. This job was a pain point for many customers, as sometimes they would forget to run the job or provide bad input and eventually run into errors within SYSVIEW. So, starting at SYSVIEW 16, there is no need to ever run a profile conversion job again. SYSVIEW 16 Oak introduces dynamic profile conversion, where a user profile will be automatically converted. This concept also keeps old versions of the profile in order to be compatible with older releases. I will now switch over to SYSVIEW to demonstrate SYSVIEW user profiles. Okay, I will now demonstrate some different things regarding profiles from within SYSVIEW. So by using the profile general command, I can see different options for my profile. If I go down to the miscellaneous section and select it, I can see different options that I have for my profile. There's a lot of different things you can change here. Just to demonstrate something, I will change the divider line character. This is the character that is used to divide the different areas up at the top of the screen. So if I change this to an equal sign and press enter, you will see my display change slightly up at the top and bottom of the screen. Now up at the top information area, you can see the status of my profile, which is currently in the altered state. So if I wanted to immediately save my changes, I can do a profile save, and that will change it back to the default setting of being in read-write status. Now profiles are automatically saved when you exit your SYSVIEW session, but you can immediately save your profiles using profile save. So one other way to change that divider line character is by using the set keyword over to the right hand side. So if I copy this divider char, I can use the set command, pass that divider char as a parameter, and then actually give it a value. So if I wanted to go back to the periods like I had before, I can pass the value of periods, and that will change my divider char back to the period, and we can see the status is once again changed to altered. So if I PF3 back here, I was currently sitting on the activity command, and like we discussed before, you can see the filters here, or the different formats here. So if I wanted to create my own formats, I would type in the profile command, right on this display, and this will show me my profile settings for the activity display. So if I select the format section, select activity there, we can actually add a new format. So if I wanted to call this new format just test, we can see all the different columns that are shown on the activity display. So if I wanted to move one of these columns, let's say we wanted to move the address space ID up before the cross system indicator. We'll do a move on the ASID and then a B for before on the XS system, and we'll actually see that the ASID column should now be displayed first. So if I PF3 out of here, that should save it. Let me PF3 back to the activity display. And in the format section, we actually have a new format here called test. So if I were to select that here, we can see the address space ID column is now the first one. So as mentioned previously, you can actually see help for every command from within SYSVIEW. You can do this by using the PF1 key, and that will display the help member for that given command. At the top, you can see a summary of what the command actually is. Table of contents, you can see what else the help member provides. For example, the command syntax, parameters that you can pass, description of the fields that are on the command, and so on and so forth. Also, as I mentioned before, there's a topics command which shows different articles related to SYSVIEW concepts that you might find helpful as a beginner, so be sure to check it out. One of the main purposes of SYSVIEW is to alert you when something bad is going on with your system. Throughout the data collection process, over 1,500 metrics are collected and available for monitoring. As mentioned previously, SYSVIEW allows you to create custom thresholds in order to define what values should be considered problematic. A threshold definition consists of what metric this threshold is pertaining to, a limit value, a warning value, possibly a resource, for example a job name, what actions to take, and several other settings. So, for example, you could define a threshold for the CPU percentage metric with a limit of 95%. If the data collection process determines that the CPU percent value is 95 or higher, whatever action is defined on the threshold will be taken. There are several other options that can be taken advantage of to fully customize the threshold definition, but they are outside the scope of this presentation. So, when defining thresholds, take a glance over all the options available either through the online help or on our DocOps site. Very similar to thresholds are states. State definitions also allow you to define values that are considered problematic in your environment. The values for these definitions, however, are not numeric. Rather, they are defined character keywords, also known as states. For example, a CICS region can have the state active or the state inactive. You can create a state definition to be alerted when a certain CICS region becomes inactive. State definitions have similar settings to thresholds, so defining the two are almost identical. States and thresholds can take several actions when a metric is deemed problematic. Some of these actions include writing a message to the log or console, sending an email, sending a notification to CA Ops, or even executing a rex exec. Thresholds and states are held in ParmLive members, but can also be defined online from within SYSVIEW. However, remember that online changes are saved to the persistent data store, so that definitions will not be saved if a cold start is used. When dealing with data, sometimes you want to get a historical view to see how your system has been performing over time, or maybe even get a visual representation to make it easier to comprehend. To allow for these common practices, SYSVIEW has reporting capabilities. SYSVIEW can work either with Report Writer or EasyTrieve to produce tabular, plot, or graph reports. The input for these reports normally comes from SYSVIEW log streams. Also available from within SYSVIEW is the plot command. The plot command allows you to plot a given metric over the past hour. This is a great way to quickly see how certain areas of your system are performing. The screenshot to the right shows the metric job CPU percent with the resource of SYSVIEW plotted over the last 60 minutes. This means that we are seeing the CPU percent for the job with the name SYSVIEW. One common activity done within SYSVIEW is the viewing of logs. There are several different scopes that these logs may cover, including system-specific, SYSVIEW-specific, or job-specific. To start with, we will discuss some system-specific log commands. The syslog command will display the current system log dataset. This log is constantly being updated from sources all over the system, and the syslog command allows you to see the updates to this log simply by refreshing the display. SYSVIEW also has a WTOR command that can be used to respond to any outstanding WTORs. Similar to syslog, the logrec command can be used to display summary records from the sys1.logrec dataset, which contains various exceptions and errors from across the system. Next are the SysView specific logs. The lg logs command will show you a list of data collection logs specified in the parmli member lg lookup. This display can be used to see some details about the SysView log streams, like whether the log streams are active, the dataset names you defined for the log streams, and the time span covered within the log stream. The list log command will display information about the current SysView session. For example, if you entered a string of commands to get to a current display, but forgot what actions you took to get to where you're at currently, you can check the list log display for a history of actions taken in the current session. Every SysView log stream has a respective command to view the log stream online. The audit log command is just one example of this. SysView's audit log will display events recorded by the audit component, which for example could be an audit event like session log-ons or log-offs. Finally, job-specific logs. To view the output of a given job, you can use the output command, passing the job name as a parameter. This command will allow you to see the output datasets for the given job. Viewing job output is made much easier by using other job-specific commands like activity or job sum. These commands have a row of data per job, and line commands can be used to view the output datasets for a given job. I will now switch over to SysView to demonstrate the viewing of the different types of logs. Okay, I will now demonstrate the viewing of different logs from within SysView. First, we'll use the syslog command to view the system log dataset. Now, since this dataset is written to from all over the system, it is written to quite often. So if we press enter on this display, it will actually refresh, and we can see that the display actually refreshes, showing the updated version of the system log dataset. Next, we'll hop over to the list log display, which will show current session activity. So on the right-hand side in the data column, towards the bottom, you can see the commands that I entered previously. We can see that I entered syslog, followed by a bunch of refreshes, and then the list log command. Finally, I'll show viewing different job logs from within SysView. So I can use the output command followed by a job name, here SysView, to view the output of that job. Now I can also use the jobs command, pass it a parameter, to view all of the jobs named SysView on the current JES spool. Now from here I can use line commands, here L, to view the different DDs from within that job. So this is a way to get granularity into what actual DD you want to view. So if I do an S command up at the top here, I can see the JES message log DD, and that will show me only the information from the JES message log DD. As mentioned earlier, SysView allows you to monitor your entire Sysplex from one instance of SysView. SysView must be installed and running on the other LPARs, but this ability to monitor multiple LPARs from one instance is extremely convenient. This capability is made possible through SysView's cross-system services, which runs under the user interface address space. Not every command is capable of displaying cross-system data. The access commands command will display a list of all supported commands. From this display, you can define whether each command should gather data from other LPARs or not. These commands also support the excess data parameter to be passed to them if you only want one execution of the command to use cross-system data, rather than turning the switch on until you turn it back off. When taking advantage of the cross-system monitoring that SysView allows you to do, be aware of possible overhead that might occur. The more systems you are communicating with, the longer the commands might take to respond because there is much more data to collect and display. For example, think of the activity command display we saw earlier. This display was only for one LPAR and still had several hundred rows of data. If we were to turn on cross-system data for this command, we could expect to see several thousand rows of data at the cost of slight overhead increase. I will now switch back over to SysView to demonstrate SysView's cross-system capabilities. Okay, I will now demonstrate cross-system communication from within SysView that allows us to communicate with other SysViews running on LPARs within the Sysplex. So I'll use the CPU command to demonstrate this functionality. So if I hop over to the CPU command, we can see here that I am seeing information about the current CPUs running on my the current LPAR that the SysView instance is running on. Now if I were to enter CPU and pass it the excess data parameter, we will see this display change slightly. There will be one more column on the left hand side, excess system, which shows the different system names. This is how you would see information regarding CPUs on the different LPARs. From here, I can also use the excess commands command. This is another way to get the cross-system communication for the CPU command. So listed on this display is all of the different commands that are eligible for cross-system. Here we can see CPU is one of them, and if I were to overtype this column to yes, just by going to CPU now without passing the parameter, it kind of like permanently turns on the cross-system. So we can see on the left-hand side that cross-system is there. When it comes to SYSVIEW administration, the ASAdmin command is quite useful. This command will show all subtasks currently running in the SYSVIEW address spaces. These would consist of data collectors, loggers, session controllers, and several others. The ASAdmin display shows metrics on these subtasks like resource usage, and allows you to interact with the subtask. You can use line commands to interact with the subtask, and some simple actions you might take are starting or stopping a subtask. This command is great if you are curious about how much an impact SysView has on your system. I will now do a demonstration of ASAdmin. Okay, I will now do a demonstration of the ASAdmin command display. Now this stands for Address Space Administration, so this could be useful if you were curious at how much overhead SysView is actually creating. So on the left side you can see an indication of the SysViews that we're currently running. Under the task column you can see the subtasks that are running within that address space. On the right you can see information regarding the resources that those address spaces and the individual tasks are actually using. So this would be useful in how you could determine how much overhead SysView is actually creating. So from here you can actually start and stop different subtasks. Say you didn't want the IMS CQS subtask to be running, you're not using it, and it's creating too much overhead. So you can actually do a stop right here, and we refresh the display, and we can now see the status is inactive. And then also from here we can do the same thing with start, and the subtask is active again. The final concept that I want to cover in this presentation is that of address space switching. Most commands within SysView are not specific to a single address space, however there are quite a few that are. For example, the tasks command will display all tasks running under the given address space, or the gprivate command, which will display private storage usage above the 2 gig bar for the address space. How you connect to SysView will determine what your default home address space is. For example, if connecting via VTAM, your default address space will be the SysView user interface address space. If connecting via TSO, your TSO user session address space will be the default. To switch address spaces from within SysView, you can use the ASID function command. This command allows either a job name or an address space ID to be passed as a parameter. This command will then switch your session to the given address space. If you issue this command without any parameters, you will be taken back to whatever your default address space is. If you are unsure of what your current address space is, you can use the query function command. This command can be shortened to Q, as seen in the slide, and you can either pass the keyword ASID or job name to see what your current address space or job name is. I will now switch back over to SysView one final time to demonstrate address space switching. Okay, for the final demonstration, I will demonstrate address space switching from within SysView. So to do this, I'll go to the tasks command. This will show tasks running in the current address space that I'm under. So if I don't know what address space I'm currently in, I can use the query command shortened to Q and pass it ASID. This will show that my current ASID is 02EA. I can also use the query command to see what my job name is under my address space. Now from here, I can use the ASID command to switch address spaces. So say I wanted to switch into a SysView user address space. I can pass the name of the job, which is sysvdevu here in this case, and you will see this display refresh with the task running under that address space and job name. That concludes this presentation. I hope you found it useful, and be sure to check out our DocOps site to find all information regarding CA SYSVIEW performance management. Thank you.